Okay, just like we had a look at arithmetic series, which is the sum of an arithmetic sequence, now we're going to have a look at geometric series, which obviously is the sum of a geometric sequence. Geometric series work a little bit differently to arithmetic series though. With an arithmetic series, if we added up every single term in an arithmetic sequence, our answer would either only be positive or negative infinity. Because if you think about what's happening in an arithmetic sequence, it's just adding a single number each time, so that each term is getting bigger and bigger and bigger each time. Or if we're adding a negative number, the term is getting smaller and smaller and smaller each time. Either way, if we add up all of the terms, we're going to end up at positive or negative infinity. With a geometric series, however, it behaves differently whether we're adding up some of the terms or all of the terms in a geometric series. So first thing we need to work out is what's the difference between an infinite geometric series and a finite geometric series, and it's all to do with the sequence that's being summed. So for this left-hand example here, we've got an infinite geometric series and we would be adding up an infinite geometric sequence. And this sequence is infinite because the dots at the end tell us there is no end point. We just keep going on until we theoretically arrive at n equals infinity. On the right-hand side, we've got a different example of a finite geometric series, and this is the sum of a finite geometric sequence because the last term is specified. So we add every term in this sequence, including all the terms in the middle, but stopping at 768. So if we're adding the first n terms of an infinite geometric sequence, we're calculating a finite geometric series. If we add all of the terms, we're calculating an infinite geometric series. And the formula are slightly different. So for a finite geometric series, and reminder that that is the first n terms, the general formula that we use is this one in the box here. So for the general geometric sequence defined by Tn equals AR to the n minus 1, the sum of the first n terms is given by either of these two formulae. It doesn't matter which one you use. One you'll have double negatives, one you'll have double positives, but you will get the same answer for either version. And basically it is the sum to n terms is the first term outside of the common ratio to the power of n minus 1, all divided by r minus 1. We've got the condition that r can't equal 1 because if we do, then the denominator is 0 and the whole thing is then undefined. The formula is generated here below. If you like, you can have a look through and see how that is stepped out. Probably the biggest thing that you would need to be aware of is that when we get to this second step here, what we've generated is most of what we've generated in the first step. I'm not going to go through that. You would never be asked to reproduce that. I just think it's interesting, especially for those of you heading towards specialist next year. In the next example, and next video rather, I'll go through some examples.